I'll go over that in a minute. So if we are going x plus 6, y minus 5, Jose, you weren't here yesterday. Alondra, where are we going if we're going x plus 6, y minus 5? We are going right 6, very good. And where else? Down 5. So we are going right 6 and we're going down 5. So we would take, and on your paper, you're not going to be able to actually drag the rectangle. You'll have to redraw it. But we're going right, let's see.
Oh my God.
1, 2, 3, 4, 5, 6, and then down. 1, 2, 3, 4, 5. Woohoo! Okay. Now we need to find out where L prime, M prime is. Remember, when you translate a point, it goes from the letter A to A prime. You call it prime when you translate a point. Okay? So LM was the right side, or is the right side of the rectangle. So it's still going to be the right side of the rectangle. So it's asking what line that segment lies on. So we had to name the line. We had to name it. Not Bob or Shirley, but like the name, the equation of the line. So here's the x-axis
I'll name it Chris.
and the y-axis.
Wait, no.
This line right here, which axis is it hitting? Good. It's hitting the x-axis. And then all you have to do is figure out where it's hitting the x-axis. Where is it hitting it? What number? 1. So Trent, what's the equation of the line?
Oh, I don't know the answer, but I have a question about number 7.
Okay, well I need you to answer the warm-up first. What's the equation of the line? It's hitting the x-axis, and it's hitting it at 1. So what's the equation of this line right here?
2 comma.
X
Uh-huh.
equals 1.
That is the answer to the warm-up. Yay, very good. Reflection. So what was yesterday? Translation. Awesome. So we're only learning 3 of these. Yesterday was translation, today is reflection, and tomorrow we will do rotation. So we're in our notes on page 2. Some of you put your notes over here in the tray. Lillian, DJ, Alondra.
Chris, you have a plan for
A reflection is also known as a flip. We are going to flip our figures today. Figure flip. And when you reflect something, you can't reflect over a point. We're always going to be reflecting over a line. So we're going to have to name some more lines today. Okay. So we are always going to reflect over a line, and that line is going to be called the line of reflection. That's not too difficult.
Do you think about warm-ups?
Yeah. When you reflect a figure, every point and the image are going to be the same distance away from the line of reflection. So if this is the line of reflection, and this point is 2 to the left, then this point on the pre-image would be 2 to the right. They're going to be the same distance, equidistant away. Let's see if it says what you're supposed to fill in. No, it doesn't say. In your notes, there's a blank to fill in, right?
What are those pictures?
Oh, I'll go back. When a figure is reflected, the image is, what do you think the answer is? Congruent. Very good. The image is congruent to the pre-image. That goes in your notes. Because we're not going to change the size or the shape. We're just going to change the position. So we're not changing the size, we're not changing the shape. Just the position of the figure. Okay, so that word was congruent. That goes in that blank. Okay, here are some pictures of reflections in the real world. We've got Venice with the buildings, and you know how they have like water as their roads. They get around in boats. We've got a large marble. We've got a war memorial. We've got the astronaut's mask. That's the eye of a bug. There's a cute little bird looking at himself in the mirror. Rear view mirror of a car. And then every time you have water, you have
That picture
reflections.
is actually really bad, astronaut.
Okay.
You get it? I didn't want to say
Uh-huh.
I didn't want to say that.
No, I get it. Yes. Okay, so I really think y'all can do this. I want everyone to go to number 1, and I want you to reflect ABC over the x-axis. Just do it without without me leading you. Reflect ABC over the x-axis. They shouldn't all become negative. I'm gonna let you figure out what, but not all of them become negative. Make sure you get the same coordinates as I do for ABC. Make sure I did it right. And we're going to discover a pattern, something that happens when we reflect. Now the green line, the x-axis, is the line of reflection. So when you're reflecting this triangle, you're asking yourself, how far away is A from the green line? How far away? It's 3 away. So A is 3 above the green line. So for A prime, I'm going to go 1, 2, 3 below the green line. And I now know where A prime is. That's what reflecting is. How far away is B from the green line? 7 away. 7 above the green line. So I'm going to go right where B is. I'm going to go 1, 2, 3, 4, 5, 6, 7 below the green line and put B prime. Good. C is 2 above, so I'm going to reflect it. It's going to be 2 below, C prime. Connect the dots, and now we have a beautifully reflected figure. A prime, B prime, C prime. Okay, so Lillian, what are the coordinates of A prime? Come over your paper. A is 2, 3. What's A prime?
Oh, it's 2.
Awesome. DJ's not here. Haley, what's B prime? What are the coordinates of B prime? Absolutely. And Araceli, C prime. Thank you, Trent. Awesome. I want everyone to look at the coordinates of A, B, C, and then I want you to look at the coordinates of A prime, B prime, C prime, and I want you to come up with a conclusion. Don't say it out loud. Just come up with, or a hypothesis rather. Hypothesize something that happened between going from these numbers to these numbers. Just don't say it out loud yet. Hold it inside. Who would like to share their hypothesis? Jacob?
That side turns to negative, which is x, right? The right is the right x or is that y? Y
Okay.
turns to negative.
And what happened to the x's?
It's nothing.
Nothing. So, wait, what axis did we flip over? Which axis? So I guess when you flip over the x-axis, you make all the y's negative. And when you flip over the y-axis, you're probably going to make all the x's negative. Okay? That's not too bad. So here's the rule right down here. What does x become? X becomes x, because nothing happens to it. And y becomes negative y. Write it down. That's the rule for reflecting over the x-axis. See how these stay the same? 2, 4, 7, 2, 4, 7. And all that happened to the y values are they became negative. Their sign changed. Opposite sign. Okay, now I want you to try and reflect over the y-axis. Go for it. Draw it. Reflect DEF over the y-axis, just like we did with ABC, except now it's a different axis, please.
What do you mean?
Over the y-axis. It's giving us a lot of practice with our coordinates.
So did they ever fix your board or what? You send them that video?
I did send the video.
It was kind of blurry.
It was, but they got the idea of it.
Yeah, they got you on video.
Oops. This one's F. Check your coordinates with mine, make sure I counted correctly. Okay. So F is 2 to the left of my axis. So I'm going to go 2 to the right, F
I messed
prime.
up.
E is 8 to the left, so I'm going to go 8 to the right. E prime. D is what, 7 to the left. I'm going to go 7 to the right. D prime. So there's the reflection of that triangle.
Oh, I went the other way.
You did the x-axis. We're reflecting over the y-axis. Okay, ready? Savannah, coordinates of D prime.
7, 8.
7, 8. Trent, E prime.
So it'd be
Just take this and change that.
8 and 2.
8, 2. And Ruth, E, F prime.
3 and 2.
Well, don't switch them.
Oh, 2 and 3.
2, 3. So we took all of the x values and what did we do? Made them positive, but I want you to think of, we made the negative, but what is a negative negative 7? It's a double negative, it's a positive, remember? You turn it into a plus sign. So the rule is we took all the x's and we made them negative, and we took all the y's and we did nothing to them. So the rule is negative x comma y. So like I said before, if you flip over the x-axis, you make the y negative. If you flip over the y-axis, you make the x negative. It's the opposite. Okay? Do we need to try? No, you don't need to try. That one's not even on yours, is it?
We could do it.
Nope, we don't need to. Here's the most important slide of the day. Make sure you write this down in the box where it says rules with the stars around it. These are the 3 rules. Reflection across the x-axis is x negative y. Reflection across the y-axis is negative xy. And this one's new. Reflection over the line y equals x. Do y'all know what that line looks like?
Yeah, it goes like this.
Oh, it's a parent function, yeah.
Yep.
That's the line y equals x right there. We could reflect over that line even. We can reflect over any line we want, actually. So you wrote down all 3 rules, sorry? So we know what happens on this first rule. You make the y negative. We know what happens here. You make the x negative. What happened on this last rule? What's different?
Well, if you're using a parent function,
What'd you say, Jerry? It flipped.
Yeah.
It's like Freaky Friday. They traded places. Where the mother and daughter trade places? No,
Haven't
maybe
seen
not.
that movie in
Okay.
forever.
XY became YX. Did anyone change their sign? Someone from positive to negative, negative? No, they didn't change their sign. They just traded places like Freaky Friday. So, all right.
That was good.
What line has this star been reflected over? Nope.
Not even.
Nope.
Pretty sure that's kind of crooked.
What line has the
Y
star?
equals
It's not
X.
one of the 3 that we have a rule for. It's not one of the
asking
3.
us?
So, to find the line of reflection, you're really trying to find it's kind of like the midpoint, except it's not a point, it's a whole line. So you're trying to find out what line all the points of star number 1 would be the same distance from as star number 2. Trying to find the line that would be right smack in the middle of those 2 stars. And now the problem is we actually have to name it. Were you saying it or not? I don't know who was saying it. Oh. Awesome, yes. So which axis are we hitting? With that green line, which axis am I intersecting? The y-axis. So you write y down. Where am I intersecting the y-axis? At -2. That's how you write the equation of a straight line. Write it in your notes. It asks you in your notes. So the answer is y equals -2. That is the line of reflection. Y equals -2. So we're not always going to reflect over the x-axis or the y-axis. We can reflect over whatever line we want. Try that one. Write it down in your paper.
Is that even on a point?
No, we're not doing points. We're doing lines.
I know
There is a line that is right smack in the middle of those two checks. And I want you to name it.
1, 2, 3, 4, 5. Or 4.
Probably 4.
This is not a horizontal line this time. It's a vertical line, right? So is it going to be an x equals or a y equals? It's hitting the x-axis, so it's going to be an x equals. And where does it hit the x-axis? 1, 2, 3. X equals 4. Raise your hand if you got that right. Or I should. Yay! Okay, good. Oh, okay, this is the tricky one. This is the weird one. It says to reflect the rectangle, you have one too, over the line y equals x. We have to reflect it over that line. Go ahead and draw that line in. I think I should be able to click it to reveal. Come on. Come on. I guess it's hidden. Oh, undo that. I
That's the answer?
had the line hidden, and I was going to click to reveal it, but I'll draw it with you guys. The line y equals x is the one that goes right through the middle, through all those intersections right there.
You're like so focused.
Was I so focused? Okay, so we're going to take this guy and we're going to flip it over that line. Now, to do that, we're going to need some coordinates. So,
1/2.
no, we're not doing any halves, thank goodness. What is the coordinate of that dot right there? What's the coordinate?
2, 3.
Oh, nice. 2, 3. Look at your rules. How do you reflect over the line y equals x?
3, -2. Or
It's
2,
3, 3.
-3.
Freaky Friday, just switch places. Don't change anything.
3, 2.
3, 2. So I want everyone to plot that point. 1, 2, 3, 1, 2. 1 down, 3 to go. Okay, I'm going to change colors. Let's do this point next, right here. What are the coordinates of that point?
There we go. 1, 9.
2,
No, 2, 2.
2, 8.
8.
It hit that 10.
So Freaky Friday, switch places.
8,
8, 2. So now we need to plot 8, 2. 1, 2. Okay, I bet if we just do one more point, we'll be able to connect the dots, right? Okay, what are the coordinates of this point right here?
All you have to do is go down by like
Right.
Negative
-5,
3.
3. But we're going to practice using our rule. We want to use this rule. So we're going to trade places 3, -5. 1, 2, 3, 1, 2, 3, 4, 5. Now I'm going to connect my 3 dots and finish out my rectangle.
It's too big of a rectangle to be.
It's my red and green rectangle reflected over the line y equals x. Whoa! That's what it looks like. It does kind of look extra long, doesn't it? From here to here. I promise, look. If I rotate this, and then put it here.
That's
Whoa, it's
translation.
perfect!
the translation.
I did, I rotated and I translated it, but it really reflected over the line y equals x. Okay, the next thing we need to talk about real quick is symmetry, because symmetry goes perfectly with reflections. If an object is symmetrical, then that means that you can map every point onto itself. So that means if I were to look to the left of this dotted line, it would be identical to the right of the dotted line, right?
Bruh.
How many lines of symmetry would a regular hexagon have? Remember, regular just means all sides are congruent, all angles are congruent.
6, no.
How many lines of symmetry? Start drawing some on your paper. Draw a line of symmetry. Like there's a line of symmetry. Everything on the left matches everything on the right. And see how many you can draw.
Are you serious right now?
I'm serious right now. You're doing the pentagon. Jared, do the hexagon.
Oops. Yeah, I'm pretty sure it's 6.
I'm doing side to side, side to side, side to side.
I see three.
That's 3.
It's a T.
What else can I do?
One.
Vertex to vertex, right? Would that be a line of symmetry? Oh, I understand drew it correctly. It would be
And then,
vertex to vertex,
Oh, wow.
vertex to vertex,
and then the middle.
It's more.
vertex to vertex.
12.
See any more?
We should do this with a circle just to make fun.
12.
A circle has an infinite number of lines of symmetry. You're right, Jacob. 6 is the answer. There are 6 lines. There's 6 lines right here. 6 segments. 6 lines of symmetry for a hexagon. Now, a hexagon has an even number of sides. What's going to happen if we try one with an odd
It's not
number of
gonna
sides?
work.
I can't draw side to side, right? Is that a line of
You
symmetry?
can only do one.
If I flipped this over, would it map? No. So, does it have any lines of symmetry?
It has
Yeah, they have 1,
2.
It has just one.
If you flip it.
We don't need to flip it.
Oh.
So I went vertex to side, right? If it's regular, all sides congruent, couldn't I do that with any of them? Vertex to side, vertex to side. Do I have any more?
Yeah,
Vertex
that's
to
the
side,
That's why I said flip it.
vertex to side. How many did I draw? How many vertices
1,
are
2,
there?
3, 4, 5.
It's a pentagon. There's 5. So what's your conclusion about a regular polygon and the number of lines of symmetry that it has?
It's the same number as this one.
Same as the number of sides. Very good. So a regular polygon has n lines of symmetry. What does n stand for? Remember, n minus 2 times 180, remember from polygons? N is the number of sides. Okay. What letters in the alphabet do not have reflectional symmetry?
B, C.
Q does not.
Z.
Q
Zero.
does not.
I mean
Z
zeros.
does not. A does.
K.
does.
Whoa.
Oh, yeah.
K does
K and L.
not.
KLJ.
I.
L does not.
I.
J does
T,
not.
G.
I does.
G, F,
T,
F, G,
D,
T does.
D.
what? Oh.
You put right down the middle. D does right here.
S.
Oh.
Right here. S does
B.
not. S
B.
is just like Z. B totally does.
No, it's a.
Yeah.
The top
It
part of it
depends
is
on what
lower.
font you use. It depends on what font you use. P doesn't. R doesn't.
Does E does?
E definitely does. Right here.
Duh.
Depends on the font.
N doesn't. N is just like Z, right? If Z doesn't, then N doesn't.
N doesn't.
Reflectional symmetry.
W.
W
Oh, yeah,
definitely
it does. You go
does.
make a B.
Did you get them all?
Yeah, I think so.
And B is debatable, and what was the other one we said was debatable? I think just B. B is debatable.
And E.
And you.
And E, because sometimes you don't put it right in the middle. I always put mine right in the middle. Where do you put yours?
I write.
Do it
Like that?
lowercase. Do it lowercase.
Well, oh, we're not talking lowercase, because then there's the line of symmetry right there.
I write with E. So.
Oh, if you write it like that,
Yeah.
it might still, but if that one's smaller and that one's larger. Okay. Anyways, when you translate or reflect an object, the image is blank to the pre-image.
This is how I write my B's. That's why.
Congruent.
Congruent! Yay! Ready to practice?
C.
I think that's all we have. Yay!
You would be in.
No homework.
Oh.
Shoot, got
You want to record?